Hello everyone, good evening. Welcome to the second session. In the first session we observed what are the topics to be covered related to GATE and ESE exams with respect to different branches. Today I want to discuss some standard models that will be repeatedly touched in exams. Repeatedly they are trying to give the type of models. So some 3 to 4 different examples or models we can say I selected in different topics. So let us go into the details. Last session we observed some basics related to introduction and convolution topics. Suppose if we want to deal with Fourier series, the aim of Fourier series is representing a periodic signal in terms of multiple sinusoidal components as sum of sine function, cosine function with the different harmonic frequency components. Generally we are dealing with the two forms of series. One is trigonometric form, the other one is exponential or complex Fourier series. What is the trigonometric general form? It will have 3 components: a0 plus sigma n equals to 1 to infinity a n cos n omega naught t plus b n sin n omega naught t. Of course, here we are getting only one-sided spectrum. When we want to draw the spectrum, Fourier series coefficients graph, it is one side. But in exponential series, what is the modification? Summation varies from minus infinity to infinity Cn e power jn omega naught t. Here we will have two-sided spectrum. Two-sided spectrum because the summation ranges from minus infinity to infinity. Trigonometric one-sided, exponential is two-sided. Most of the exams they will denote the exponential Fourier series coefficient certain times with symbol AK, like Cn, they are going to represent with AK symbol. So let us see what type of models will be touched related to this. So this is the standard model for GATE or ESE related to effect of symmetry on Fourier coefficient. Generally we are taking 3 combinational symmetries, 3 different forms. When you have even symmetry, we know the time domain condition is gt equals to g of minus t, for which bn, sine terms, doesn't exist. Odd periodic function means dc cosine, a0, a0, 0, only bn exists. Half wave symmetry contains only odd frequency components. Odd n means it contains only odd frequency components. So this is a standard table, you must be thorough. Fourier series, if anyone is willing to give a simple model, they will frame related to this table. Please make a try. Please observe this model. The trigonometric Fourier series for the waveform shown below contains which terms? Indirectly we have to check its symmetry. Indirectly we have to check its symmetry. When you see the graph, this is the reference period for us, minus t by 2 to plus t by 2. That is the reference period, which is looking like perfectly even symmetric. It is perfectly even because f of t equals to f minus t, the folded version also same. It has even symmetry perfectly. But if you see the amplitude level of the given periodic waveform, above a, below minus 2a is there. Above plus a, below minus 2a means it will have negative DC more. When the positive negative amplitudes are equal, there is a chance of DC 0, but the positive negative amplitudes are not equal here. So it is exhibiting even symmetry means cosine terms with negative DC. With negative DC because above amplitude level is a, below amplitude level is minus 2a. Negative excursion has more amplitude level minus 2a. Okay. So cosine terms with a negative DC component. So this type of models they will frame. So for that you must be thorough with this particular table. Okay. So option C you can say. This is also one more standard model. RMS value of the periodic waveform shown in figure. RMS value. RMS value is nothing but square root of power. RMS value is square root of power. Probably you are aware the power of any periodic signal is concentrated within one period. Power of any periodic signal is concentrated within one period. Assume like xt. So what is the power in x of t? You can say 1 by t integral 0 to t mod xt whole square dt. Mod xt whole square dt. So we are in a position to find out the power for one period. But there is no need to waste our time. If you take a rectangular pulse of width t having amplitude a, the fixed energy answer is a square t. This indirectly represents energy for one period. This indirectly represents energy for one period. When you take a triangular segment of width t with amplitude a, the fixed energy is a square t by 3. So directly apply that logic here. 0 to t by 2 triangular segment, t by 2 to t rectangular segment. So when you try to calculate the power, so for this portion 0 to t by 2 portion, what you can take according to that standard relation? Minus 6a whole square, minus 6a whole square into t by 2 by 3. What about the rectangular segment? 6a whole square, width is t by 2 by t. You try to simplify it is 24a square. Try to simplify. As RMS value is asked, square root of power. Square root of 24a square. So because of these predefined relations, without finding this ramp expression and wasting our time, directly we can apply that logic. It is also a regular model. RMS value of a periodic signal is also one regular model. Here we have two segments, 0 to t by 2 triangular segment, t by 2 to t rectangular segment. Use these predefined relations. We are in a position to get that result after further mathematical simplification. Okay. Let us see the one more type of question. This one. A periodic input signal, that is a given graph, shown below is passed through an LTI system with certain frequency response. Input is periodic function. It is passed through an LTI system with frequency response. What frequencies or which frequencies are present in the output? This is a standard model related to all topics. It may be given from Fourier transform, Laplace also. Input passed through system, get the output. As it is a periodic function, we have to deal in Fourier series domain. Because the system is given in which domain? Frequency domain. We want to pass this signal through a rectangular spectrum. It is an ideal low pass filter. That is covering which range? Minus 4 pi to 4 pi. Minus 4 pi to 4 pi. So first you get the output, then we are in a position to know the result. Indirectly, write the trigonometric form of this function. What type of symmetry it satisfies means, of course, it 100% contains DC because it has completely positive amplitude. After removing the DC, you can feel a odd and half wave. Try to remove the DC, then you can feel odd plus half wave symmetry. So our job is calculation of A0 as well as Bn. if you calculate the DC value, if you calculate the DC value and Bn, the trigonometric coefficient, we are in a position to know which frequency components of the input are passed through that filter. What is the cutoff for the filter? Cutoff frequency is given as 4 pi. So make a try. Come on, make a try. I am giving some time for you. I am expecting answer from you. Make a try. What is that A0 value? Very simple. Area of the signal over one period by fundamental period. A0 is simply 5. Area of the signal over one period by fundamental period. Similarly, try to get Bn. We have to get Bn. So I am moving to next slide. What is Bn definition generally? 2 by t integral of x of t sin n omega naught t dt. Sin of n omega naught t. So from the previous slide, this is one period, but within the time period it covers from 0 to 1. 2 by 2 integral 0 to 1, amplitude of that function is 10 sin n pi t. Further, minus cos n pi t by n pi over the limit 0 to, so 10 by n pi 1 minus cos. Of course, the general solution of cos n pi is minus 1 whole power n. So it is simplified like 20 by n pi for odd frequency, 0 for. After solving Bn, we got the answer only for odd harmonic components. That itself indicates half wave symmetry. We are defining Bn means odd symmetry, but that Bn answer is strictly valid for odd frequencies. That indicates extra half wave symmetry. So now we are in a position to know A0 value as well as Bn value. So what is the TFS form of input? You can say trigonometric form of input. For that waveform, you can say A0 plus means 5 plus sigma n equals to 1 to infinity. No an 0. Bn is strictly valid for odd harmonics, 20 by n pi sin n pi t. 20 by n pi sin n pi t. Why I am writing omega naught as pi? Time period is 2. Omega naught becomes how much? Time period of the graph is, so omega naught becomes pi. Sin n omega naught t form. Sin n omega naught t form. So we are expanding this summation only for which frequencies? N plus 1 means 20 by pi sin pi t. N plus 3 means 20 by 3 pi sin 3 pi t. N plus 5 means 20 by 5 pi. Like that, only odd frequencies will be retained apart from DC. But in our example, what is the cutoff frequency for the low pass? This is ideal low pass filter rectangular spectrum. What is the cutoff? 4 pi. So our output can retain only which frequencies? As the amplitude of the filter is 1, output can retain only 3 components. So what is the output of the filter? You can say 5 plus 20 by pi sin pi t plus 20 by 3 pi sin 3 pi t. So output has retained only 3 frequencies for us. Theoretically, what you can say? 5 means DC, pi corresponds to first harmonic, 3 pi corresponds to third harmonic. Output has retained only three terms: DC, first harmonic as well as third harmonic. So to solve this type of model, what is the first thought we need? Input signal is given in time domain. Our system is given in frequency domain. What is the job of that system? It will pass our input frequencies which are less than or equals to 4 pi, indirectly get the frequency domain form of periodic function. Periodic function frequency domain means what comes into picture? Fourier series. Once you got that idea, after that verification of symmetry, calculating the respective coefficients, easily you can say the answer. Very easy. Okay, I am moving to next slide. Some regular competitive exam models we are going to discuss in today's session. Regularly that are repeated. That type of models are compulsory in competitive exams. Okay, I am moving to next slide. Study this. This is also asked in one of the recent GATE paper. Exponential Fourier series form representation is given by summation. We know exponential means we have two-sided spectrum minus infinity to infinity. X of t is real and even. 3 points are mentioned about the signal. 3 points. It is a periodic signal having fundamental period of 6. Average value of xt is 2. AK, Fourier series spectrum, has amplitude of k for few frequencies 1 to 3. What is the average power? He is asking power by giving spectrum. So that is Parseval's theorem. What is Parseval's theorem in Fourier series? 1 by t integral 0 to t mod xt whole square dt equals to sigma minus infinity to infinity mod ak whole square. The total power in the periodic signal equals to sum of squared amplitude of each harmonic component. Already ak is available. Second point indicates a0 value is 2. Average value of the signal is 2. Make a try. I am giving some time for you. Respond your answers in the chat box. Make a try. Try, sir. Don't forget, in the third point he has given AK as k only for 1 to 3 range, but it is a two-sided spectrum. So how to take the answer for negative harmonics? That is available in first point. What is the first point? Xt is real and even. Xt is real and even means xt equals to x minus t. So with respect to Fourier series coefficient, what you can say? AK equals to a minus k. AK equals to a minus k. Come on, come on. I hope you are solving. So, if I draw the spectrum with the known data, AK versus k into omega naught. In our example, time period 6. Omega naught becomes 2 pi by 6. So, k into 2 pi by 6. Which numbers we have to choose? 0, 1, 2, 3, minus 1, minus 2, minus 3. From the second point, what is the average value mentioned? A naught value 2. From the last point, that is third point, what is AK mentioned? AK is mentioned as K, general form 1, 2, 3. 1 here, 2 here, 3 here. But we observed in the first point AK equals to A minus K. AK equals to A minus K. Now we got the complete Fourier series spectrum. In this example, it is varied from minus 3 to plus 3. So what is the power? Sigma minus 3 to plus 3 mod AK square. Because of its even symmetry, you can say A naught square plus 2 times sigma K equals to 1, 2, 3 mod. So 2 whole square plus 2 into 1 square plus 2 square plus 3 square watts. Very good, Satish Kumar. You should try. I'm providing 2 to 3 minutes gap for you such that it is like interactive session for us. Here, there is a chance some of the students may take only for positive numbers. They are neglecting the answer for negative number. You must be careful. From the first point, as xt is real and even, ak equals to a minus k. Based on that, we got the answer for negative harmonic also. Power of a periodic signal in frequency domain means blindly application of which property? Parseval's relation. Parseval's relation. Okay. Let me deal with the next one. I hope everyone is following me. Respond, sir. Are you following me or not? Okay. So the most important topic, like I mentioned in the session 1, first session for you, properties of Fourier transform, you must be thorough, as well as the standard signal spectrum. So just like that, I have provided the data for you, some of the standard signal spectrum as well as the list of properties. 50% of questions generally will be asked from this CTFT, continuous time Fourier transform chapter in different competitive exams. Okay. So let us see few examples related to this. For the signal shown in figure, he is expecting capital X0 and area under the spectrum. Of course, they are linked to our definition. What is forward definition? Normal Fourier transform definition is what? Integral x of t e power minus j omega t dt. We are expecting the value at origin. Capital X0 meaning is spectrum at origin. Spectrum at origin. What you can say on the right side? Spectrum at origin corresponds to area under the signal. Spectrum at origin corresponds to area under the signal. So from the given graph, how we can obtain the area under the signal? Make the shape appearing like rectangle. From that rectangular part area, try to remove triangular part area. Make it as a rectangle. From the rectangular part area, Remove the triangular part area. What is the rectangular part area? Length into breadth. What is the triangular part area? Half base height. Half into 2 into 1. Try to make the given shape appearing like rectangle. Rectangular part area 4 into 2. Triangular part area base is 2, height is 1. Make the shape appearing like rectangle. From that remove triangular part area. Spectrum at 0. Second bit, of course, linked to IFT definition, inverse Fourier. What is inverse Fourier definition? Xt equals to 1 over 2 pi integral x omega e power j omega t d omega. As we want area under the spectrum, in the second bit integral x omega d omega, our target is making this exponential as 1. How to make this exponential as 1? Try to check the signal at origin. Try to check the signal at origin. 2 pi into, take the value at origin. What is this function value at origin? Very clearly. 2 pi into 2. 2 pi into 2. Area under the spectrum corresponds to checking the signal at origin. Come on, be interactive. So this is also one regular model in exams, but the point of observation you should make the 2 bits is, when you want spectrum at 0, indirectly it is area under the signal. When you want spectrum at 0, it is area under the signal. But what happened in the second bit? Area under the spectrum means signal at origin. Area under spectrum means signal at origin. Means area under one domain corresponds to checking the other domain at origin. What is one domain, other domain with respect to this topic? Time domain, frequency domain. When you are finding area under time domain, we verified spectrum at origin. When we want area under frequency domain, we are checking signal at origin. This is also one regular competitive exam model. Okay. Application of properties. If the original signal spectrum is x of omega, x omega or xj omega means same. How to get Fourier transform of x of phi t minus 3? So what are the two properties we have to apply here? Xt became x of phi t. We need time scaling. X of alpha t 1 by mod alpha, x of omega by alpha, as well as shifting. Because of shifting, what is the extra multiplier? E power minus j omega t naught x of. So think and respond. Which is a possible answer? We want x of phi t minus 3 Fourier transform. Think and respond. What is the possible answer? So when you take internal scaling factor common, alpha 5 t naught 3 by 5. So when you apply the property for x of alpha t form, what you can write? 1 by mod alpha x of omega by alpha into shift of 3 by 5 e power minus j omega t naught times of x omega, that is already scaled. First scaling, then shifting. For x of phi t, 1 by mod alpha x of omega by alpha, shifting e power minus j omega t naught. E power minus j omega t naught. That x omega is given as x of j omega symbol there. Okay. What is the value of this integral? Integral sig square phi t. Sig square phi t means integral square of the signal corresponds to energy. If you fail in time domain, in frequency domain again, Parseval's theorem. Of course, for energy signals, the word Rayleigh's theorem is used. With respect to spectral density, apply that, you will get the answer. So here, what is the background we need? Sin AT by pi t. What is the spectrum? Sin AT by pi t, it is a rectangle from minus a to a. Use that hint. It is given as integral sinc square phi t. Sinc phi t can be expanded as sin phi pi t by phi pi t. Sinc x is sin pi x by pi x. Sinc x is sin pi x by. So according to the standard relation sin AT by pi t form, what is the spectrum we are going to take? Where the spectrum is covered? It's a rectangular spectrum that covers from minus 5 pi to 5 pi with amplitude of 1 by 5. Don't forget that. Here the rectangle amplitude 1. We have extra multiplier as 1 by. So according to this property, 1 over 2 pi, the spectrum is limited for which range? Minus 5 pi to 5 pi, amplitude whole square d omega, mod x omega whole square means what is amplitude here? If you feel this like xt, what is the amplitude? 1 by 5 whole square. After mathematical simplification, you are getting the simplified answer. Area under signal whole square or spectrum whole square means application of again the Parseval's theorem. Area under signal whole square or spectrum whole square. Okay. Let us discuss one more model. How to answer this type of questions. Again, it is asked like area under a signal. Area under the signal means spectrum at origin. One technique of solving this example is, one model to solve this example is, area under the signal means take spectrum at origin. Instead of that, it is a slight modification of Parseval's theorem. Parseval's theorem is applicable for same signals. The modified version of Parseval's theorem is called as Plancherol's theorem. Modified version of Parseval's theorem is called as Plancherol. That conjugation denotes if one of the signal, considered signal is complex, then we need this star, conjugation is needed. So here you can feel inside it is product of two functions. Luckily in our example they are real. Sin AT by pi t real. Sin AT by pi t real. Cos is of course real function. Cos is of course real function. Use the logic. So integral xt into yt, what will happen to their spectrums? 1 over 2 pi, find the area under product of the spectrums. Make a try. You can feel x of t as a 12 sin 4 pi t by 4 pi t, that as one function. Y of t as another function cos 2 pi t, cos 2 pi t. Take their spectrums and try to substitute there. Yeah, Dev, you want me to speak in that language? Concepts are finally needed. We are Indians here. Concepts are finally needed. That is most important. So, like we observed in the previous example, sin 80 by pi t form. What is the spectrum we can take? Sin 80 by pi t form, that is the spectrum directly. Cos function will have a spectrum as two shifted impulses. Two shifted impulses. When you are multiplying these two spectrums, we are in need of using the product property of impulse. What is that? X omega into del of omega minus omega naught equals to x of omega naught into del of omega minus. So simply we are multiplying the spectrums, x omega into y omega. According to this product property of impulse, if I am multiplying the impulse with this rectangle, the weight, new weight becomes 3 pi into del of omega minus. Similarly, the other one, 3 pi into del of omega plus. Normally, we know area under unit impulse is 1. Area under unit impulse. But what are the individual weights here? The weight of the impulse are mentioned to be 3 pi there. Do simplification. So in our previous example, we have seen Parseval's theorem. Area under product of same signals is like Parseval's. What is the inherent meaning of this x square t, xt into x star t? When they are different signals, it will be like Plancherol's theorem. Of course, that is 3. I am not serious about that simplification, explanation, how to solve the models that we are concentrating. So after today's session, if you cross-check the previous GATE ESE, you will get some idea what type of models were touched earlier. Yeah. Let us see some examples related to Laplace. A continuous time LTA filter has impulse response like a rectangle for certain range where a constant input value of 5. So you want to apply constant. This we want to pass through a rectangular pulse. After getting the output, what is the steady state value of output? Final value. What is the final value of output? Normally, most of the fellows, what they will do is, simply they will take Laplace of 5 as 5 by s. That is wrong. It is a constant for all time. It is a constant where we are using our eigenfunction concept. If the input is of the form k into e power st, which is passed through LTA system, the output is also of the similar form, k into e power st into h of s. With eigenfunction logic, you should answer that question. You should not treat 5 as simply 5 into ut, as it is not mentioned in the question. Constant for all time with respect to ROC logic, there is no Laplace. So we should answer that model by eigenfunction logic. So we are in a position to adjust that constant number of 5 as 5 into e power 0 into t. Then what will happen to the output, sir? 5 into e power 0 into t. H of s must be observed at s equals to 0. In the place of s, what is the respective value we got now? We can adjust 5 as 5 into e power 0 into t. This is eigenfunction concept. So calculate the transfer function, Laplace of that rectangle, substitute s place 0. Substitute s place 0. We are in a position to get the answer easily. So what is the Laplace of that rectangle? You can write that rectangle as 3 into ut minus u of t minus 3, means Laplace is 3 by s into 1 minus e power minus 3s. Ut means 1 by s, shifted version is e power minus 3s by s. So think and respond, make a try. What is the final value? Okay, I'm moving to next slide to complete the model. So what is the indirect meaning of this one? 5 times limit s tends to 0 h of s. Five times. But from our previous slide, if I replace s as 0, we are getting indeterminate condition. 5 times limit s tends to 0. What result we got? 3 by s into 1 minus e. Directly try to substitute s place 0. 0 by 0. Immediately what we'll do? L'Hospital. So numerator term, denominator term, that becomes 45. Means output number is 45. Output number is, so steady state value of output is 45. Steady state value of output is 45. Don't take input as 5 means 5 into ut and taking its Laplace, creating that number. Constant for all time, no Laplace with ROC logic. So then the eigenfunction comes into picture. What is eigenfunction definition? Input form, output form, they are same. Input is exponential, output is also exponential. With this logic, we should solve. When we are replacing s as 0, indeterminate condition, we got apply L'Hospital. After simplification, we got the result. Okay, let us go to the next model. This is funny. Unilateral Laplace of a function 1 by s square plus s plus 1 is given. We want the Laplace of t into f of t. What is the Laplace of t into f of t? Multiplication with one variable is differentiation with other variable. Multiplied by t means other domain, it becomes differentiation. Minus d by ds of f of s. Try to do the differentiation. It is like d by dx of 1 by x minus 1 by x square. That will create option D. Property application, you must be thorough. Time domain multiplied by t. When you are multiplying with one variable, other domain, it becomes differentiation. When you are multiplying by t in Laplace domain, what happened? Differentiation. Minus d by ds of f of s. Think of this model. Consider a system with a transfer function. Find the steady state response when the input applied is 8 cos 2t. Here also you must be careful. It is a pure cosine wave. For a pure cosine or sine wave, no Laplace. Cos omega naught t, no Laplace. Cos omega naught t ut, if it is a switched cosine wave or sine wave, then we have Laplace. So how to answer this type of model? Same eigenfunction logic. When you are applying the input of the form a cos omega naught t plus theta, evaluate transfer function at s equals to, convert that answer to polar form, then the steady state response is scaled version of original one. Scaled version of, once the input is passed to the system, it is introducing some magnitude and phase change. With this logic, you should answer. So, when we make a comparison with the standard form, a value 8, omega naught value 2, theta value 0. So, calculate the transfer function at s equals to j omega naught, that is j2. So, replace s as j2. Simply replace s as j omega naught. So, use the calculator R to P conversion rectangle to polar. After further mathematical simplification, this is the answer. You know every quantity, substitute here. You know every quantity, substitute there. When you apply a pure cosine or sine wave, how to get the steady state response? Replace s equals to j omega naught, means rectangle is converted to polar form. Rectangle is converted to polar form. This model can be touched from network theory, analog circuits, control, signals, everywhere. It is a common model. Once input is a pure cosine or sine wave, pure in the sense which is existing for all time, the steady state response is again another sinusoid. Okay. Let us see one more model. Have a thought. The output of a causal all-pass system, all-pass transfer function is given as s minus 1 by s plus 1. It is all-pass filter. Output is given. Find the corresponding stable input. To maintain stability, what is the requirement in Laplace domain? If you want to maintain stability, what is the requirement in Laplace domain? ROC must include imaginary axis. So here our job is, first we should solve for input Laplace, ys by hs. So 1 by s plus 2, s minus 1 by, so input Laplace becomes s plus 1 by s minus 1 into s plus. So I am not doing that partial fraction now. Where are the poles for x of s? We are having poles at minus 2 and 1. The word stability is used. So ROC must include what? To maintain that stability, stable input, ROC must include j omega axis. That is our requirement. To get the stable input, ROC is between minus 2 to 1. So when you look at the ROC, with respect to the pole minus 2, with respect to the pole minus 2 it is right side, but with respect to pole 1 it is left side. So based on the standard formulas, left sided signal means it is multiplied by minus u of minus t, right side signal means multiplied by ut. The word stable input is expected. ROC must include j omega axis. I hope the point is clear for everyone. Stable input. Are you following me? Is the point clear? Everyone? So signals, mathematical relations, you must be thorough. Apart from that, certain conditions you must be careful. Certain conditions. Okay. With respect to jet transform dt, of course, they are almost same. ROC based are regular. ROC based models are regular. So certain points I have mentioned. For a finite length signal, ROC is complete jet plane with an exception. 0 and infinity are exception. When you take finite duration signal in jet plane, discrete signal. For a right-sided signal, ROC is a circle whose radius is largest pole in magnitude. Because we are dealing with largest pole in magnitude with the two basic formulas, A power and UN, one standard relation, mod z magnitude of the pole. Another one is a left-sided sequence that will also have the same jet transform, mod z less than. For a left-sided signal, ROC is inside the circle whose radius is smallest pole in magnitude. Two-sided signal, it is bounded by smallest and largest pole in magnitude. So, jet transform means they will frame a model related to ROC. Okay. So, first let me solve some ROC questions. I will come back to this slide, the previous slides. So, think of and respond. The ROC of jet transform of this sequence. We are adding a right side sequence and left side sequence. So, A power and UN form. For this, the ROC mod z greater than 5 by 6. It is right side. But this is left side. Mod z less than 6 by 5. Do we have intersection ROC or not? It lies between 5 by 6 to 6 by 5. It lies between 5 by 6 to 5 by 6 is approximately 0.8. That is 1.2. It lies between two circles, 0.8 and 1.2. 0.8 and 1.2. In a similar way, think of this ROC. Previous one is very simple. Think of this one. 1 by 3 whole power mod n added with minus 1 by 2 whole power in un. Modulus of n meaning is it is plus n for positive index, minus n for negative index. What is that? Possible ROC here. Think and respond. So in this example, we can adjust the first function as 1 by 3 whole power mod n can be adjusted as 1 by 3 whole power n for positive index, 1 by 3 whole power minus n for negative index. So the first function can be written as what? Positive index, it can be written as multiplied by un. 1 by 3 whole power minus n is 3 power n. Negative index means it is stopping at minus 1, minus 1 by 2 whole power n. First one is a two-sided sequence, modulus of n. So out of 1 by 3, 1 by 2, there are two poles, 1 by 3, 1 by 2. This is more. Of course, this is left side sequence. So ROC lies between 1 by 2 to 3. A power mod n form. A power mod n form. First one is sum of right and left sided sequence. We need an adjustment there. Okay. Yes. How to answer this model? Again, eigenfunction concept. An LTI system is having impulse response. Find the output when you apply input as e power j pi by 4n. E power j pi by 4n. Input exponential means output also exponential. When the input is of the form e power j omega naught n, output is e power j omega naught n into. To convert a transfer function to frequency response, simply replace z as e power j omega. You can obtain z transform of this one, which is hz. After that, replace z value as e power j omega. What is omega number mentioned in the question? Pi by 4. Simply you will get the answer. So let us try. Normally it is sigma minus infinity to infinity hn z power minus n. Normal definition of Z transform. But which are the valid samples? Plus or minus 2 and plus or minus. If I want to choose plus or minus 2, we have fixed amplitude of 4 root 2, that is Z square plus Z power. If you want to take plus or minus 1 minus 2 root 2, Z plus Z inverse. How it can be converted to frequency response? Replace Z as e power. Replace Z as e power j omega. After doing that replacement, first term can be written as 8 root 2 cos 2 omega, adjustment of extra 2. Second term can be adjusted as 4 root 2 cos omega. Adjust to cos theta, general form. Apply this logic. In our example, input is e power j pi by 4n. So definitely what is the output form? E power j pi by 4n into h of e power j. So replace omega as pi by 4. That will create scaling factor as minus 4. You verify. Simply substitute omega as pi by 4. Cos pi by 2 0. Cos pi by 4 1 by root 2. First quantity 0. Input exponential, output also exponential. So with respect to the duration, I am discussing the best models that are possible. So in future when we conduct certain 2 to 3 hours, long hours discussion, we can discuss some more models. The best possible models, this type of questions you should concentrate related to different competitive exams. Okay? What about this? Input is given as 1 plus 4 cos n pi. Input known, output known. What are the two coefficients alpha and beta such that we are in a position to get that output? Input side, which frequencies are there? Omega 0, omega pi. cos omega naught n form, of course, DC. So this we want to pass through system. That system expression is already given. System expression is already given. What is the output number we got? 4. So if I solve the Fourier transform of this expression, the given system expression, I can write that as y e power j omega equals to x e power j omega into 1 plus alpha e power minus j omega plus beta e power normal shifting property. It means the frequency response h e power j omega. What is frequency response definition? Fourier transform of output by input. That we can adjust as 1 plus alpha e power minus j omega plus beta e power minus. What is this black box? Our frequency response, which is known, but coefficients are unknown. The simple logic you should apply here is, input side we have two frequencies, omega 0, omega pi. Output side we have only constant, omega 0. So we can conclude that the DC response of the system means y e power j0 by x e power j0, or y omega by x omega, simply evaluate origin. Here amplitude 4, input side our amplitude 1, 4. Similarly, what is other frequency we have? Input side, omega equals to pi, which is not present at the output side. We have to check the value at pi. Output side there is no pi frequency, plus 0 into cos and pi, just for your understanding. So means 0 by 4, answer 0. You know h of e power j0, h of e power j pi, two conditions are known, two unknown values. You will get the answer. DC response, output amplitude by input amplitude at origin, omega equals to 0. Input side frequency pi is there, that is not present at the output side. Substitute here. So if I substitute here, omega value 0, 1 plus alpha plus beta equals to 4. I am replacing omega 0. Same expression, if I replace omega pi, what will happen? 1 minus alpha plus beta equals to, solve alpha to beta 1. If you do further simplification, alpha to beta 1. This is also one standard model. Maximum number of signals questions are input known, system known, get the output, or input known, get the system. For that we may use Fourier transform, Laplace. For a discrete case we may go for DTFT, jet transform. Okay. Let me discuss another question. This is a very simple. As two unknown values are there, h of e power j0, h of e power j pi, you solve and substitute in this expression, that is giving us alpha, beta, alpha to beta 1. A 5-point sequence is given, we want area under the spectrum. Area under the spectrum means, I mentioned with you, take the signal value at origin. It is actually linked to inverse DTFT definition. So you want area under the spectrum means, try to take the signal at origin, 2 pi into x of n value at origin. What is small x0 mentioned in the question? It is 5. 2 pi into small x0. Area under the spectrum means take the signal at origin. Area under the spectrum means take the signal at origin. Simply inverse DTFT definition. This is a discrete Fourier series problem, DFS. X of n is given by some expression 1 plus cos pi n by 8 having time period of 16. AK formula, discrete Fourier series coefficient definition is given 1 by n sigma standard definition. He wants A31. To answer that, we need discrete Fourier series property, periodicity property, AK equals to AK plus n. In the problem it is mentioned as 16, time period of 16. What is the general form of discrete Fourier series? Sigma k equals to 0 to n minus 1 AK e power jk omega naught n. Because luckily in the example it is given in the form of cos, expand in terms of exponential, compare. You are in a position to know that number, A31. Okay? So what is omega naught? 2 pi by n, that is 2 pi by 16. So I can write 1 plus cos pi n by 8 expansion is what? 1 by 2 e power j pi n by 8 plus e power minus. So 1 plus 1 by 2 e power j, just for clarity I am adjusting in original form ak e power jk omega naught n form. E power j. So just compare this form and this expression, from which you can say k value 0, here k value 1, here k value minus 1. Each term is neatly looking like ak e power jk omega naught n. Omega naught is of course pi by 8 very clearly. But which number is asked? A31. A31 can be adjusted as A15 plus 16. Eliminate the periodicity. AK equals to AK plus n. What is the periodicity? 16 samples. So A31 is simply A15, which is not visible for us. A15 is not available. How to get A15? AK equals to AK plus n. A15 can be obtained as, I can write A minus 1 as A minus 1 plus 16. Observe carefully. We know AK is AK plus n, same property I am using. A minus 1 can be adjusted as, A minus 1 can be adjusted as AK equals to AK plus A15. Very clearly by comparison, A minus 1 is how much? If we are not using that property, we may take wrong result. You must be careful. Standard form of discrete Fourier series is known. Expand and do comparison. Outside the range is given. Means simply application of which property? AK equals to AK plus n. So like that, there is no limit of our discussion. We can continue for so much time. So whatever the best models that are possible in this allotted time that we have discussed. Thank you for attending my lecture. Thank you for having your time, all this 1 hour duration. Do your best. Thank you.